Hello, my name is Charan Sivalingam, and this is my lab report for Lab 1. For this lab, we were required to observe the motion of an object that was moving at the same speed with no change of direction. For my video, I chose to push a phone box with another box across the length of a table. Here's the video. After I recorded this video, I analyzed the video using Tracker. My observations in Tracker showed that the velocity in the x direction was almost constant throughout the length of the video. I was able to tell this by viewing a graph of position versus time, which had a near constant slope. This indicates that the velocity of the box throughout the video was near constant. Using GlowScript, I made a model to simulate the predicted motion of the box. The initial position and the velocity were found using the data from Tracker. The time and delta t were also assumed using Tracker, using the length of the video and the length of each frame respectively. Here's the model. Using the data from the model, I was able to compare the observed and predicted motion in a graph in Excel. The graph shows that the slope or velocity of both the observed and predicted motion are very similar. This indicates that the velocity of the box was near constant. This also shows that the model created in GlowScript was an accurate representation of the real-world motion of the box. When I analyzed the video in Tracker, I made a choice of the orientation of the axes. If I had flipped the axes and the positive x direction and negative x were interchanged, the main change would be in the position versus time graph. The magnitude of the slope of the graph would stay the same, but the direction would change, meaning that it would have the same magnitude slope, but now the slope would be negative instead of positive. To say how many pushes and pulls or forces are added together to give zero net force in this case is possible. In the y direction, the two forces present are the force of gravity that's pointing downwards and the normal force that is pointing upwards. These two cancel, resulting in no net force in the y direction. In the x direction, the two forces that are present are the force of my push on the box and the force of friction, which pushes in the negative direction. Because these two are equal magnitude and in opposite directions, these two would also cancel, resulting in no net force in the x direction. That's the conclusion of my lab report. Thank you.